Good morning, dear friends. Once again, welcome for the physics lecture. Today, once again, we will start with the stuff which is related with equipotential surface. So, for equipotential surface, first we have to see what is meant by equipotential surface. Then we will write its properties. Today, I will give you notes also on that. Already yesterday we have seen all about the potential energy and everything. So today we will have a good look of equipotential surface. After that, if the time permits me, then we will go for dielectrics and polarization, and after that we will go for the capacitance. So I will suggest you to be paying good attention towards the lecture and noting down the important points whatever I am telling you. So let us start with first equipotential surface. Actually, in middle lecture, I have given you idea about the equipotential surface. So, equipotential. So, first of all, let us have the overview of this word equipotential. So, what happens? Equi and potential and surface. So let us have one surface. Suppose this is my surface, or whatever, or this is my surface. Now suppose here if the electric field is like this is the electric field. So the meaning of equi is equal and potential matlab potential. So equipotential surface, I can define it as the surface for which potential is same everywhere surface for which potential is same everywhere. The surface for which potential is 1 minute. I think there is some reflection. The surface for which potential is same everywhere is called as equipotential surface. The surface for which the potential is same everywhere. So what we can call it as? We can call it as equipotential surface. So this is the rough definition of equipotential surface. The surface for which potential is same everywhere, that we can call it as an equipotential. So we will now start to move for understanding what is meant by the equipotential surface. So first of all, at least we have got the great idea about what is meant by the equipotential surface. So for the surface for which the potential is same everywhere, of course we can call it as the equipotential surface. That is good, no problem. Now what we can do for that? We will draw a surface for which we will get this idea. So first of all, you would have you would have recalled the relation between electric field and electric potential. So electric field E and electric potential V, there are two relations. If the field is uniform, then what we can write? V is equal to ED. But if the field is non-uniform, then we are writing E is equal to minus dV by dr. यहाँ पे D मतलब distance, यहाँ पे भी R मतलब भी distance. So वहाँ पे जब हम कहते हैं, then we can express it in the form of R. Otherwise we can express it in the form of T. D मतलब distance. Okay. So these are the two important formulae. They will be helping us to discussing more about the equipotential surfaces. So suppose there is a uniform electric field. Okay, there is a uniform electric field, and suppose if I will consider one surface like this. Field is uniform electric field, and this is the surface. So here surface area is parallel to electric field. What is important? Surface area is parallel to electric field. ये जो surface area है उसका, of course area vector will be parallel perpendicular to electric field है, and area vector will be parallel to it, and area vector ऐसे area vector A is parallel to electric field. So while considering the equipotential surface, we will consider the surface which will have the total area, plane. Surface area मतलब plane containing that area, that will be perpendicular to electric field. Of course area vector will be parallel to electric field. So now what will happen? I will show you the idea how to do that. Let me draw 3 parallel lines. Those are lines of electric field. Okay. See properly. A B C D. ये आपको रिमेंबर करना है, बाजू में लिख के रखो इसको. This you have to remember every time. Very important details. What is that? If we are having this electric field, of course I can consider plus charge here and minus charge here. So once I will try to go from say A to B. Once I will try to go from A to B, then what will happen? Suppose I take a charge, plus charge, and if I am moving that charge from A to B or from B to A, if it is moving from A to B, positive charge will repel this charge, negative charge will attract this charge. So while going from A to B, potential will change. Okay, so number 1 you have to keep in mind, while going from A to B, what will happen? Potential will change. While going from A to B, potential will change. Potential will change. It will not be constant. It will change. But whereas while going from A to C, like this, suppose potential at point this, potential at point this, and potential at point this. Suppose I am moving as shown in the figure. Suppose यहाँ से उड़ा यहाँ जा रहा है. Now what will happen? I know that potential at A and potential at C will be same. Along the line it will change, but like this if I go, that will not change. So while going from A to C as shown into diagram, if we are going from A to C, potential is constant. Potential is constant. This is very important. you have to remember. If you remember this, then in your life never you will come across any problem for understanding equipotential surface. Potential is constant. So what will happen? Potential will remain constant. So if we are going along the electric field or in the opposite direction of the electric field, potential always changes. But here we are not going along the electric field. We are going perpendicular to the electric field. Correct? We are going perpendicular to the electric field. Then there is a good possibility, not possibility, then always there is a constant potential over that surface. So this you have to keep in mind as a knowledge point of view. This you may note down in your note. So I will suggest you note this down. Afterwards we will go further. Some points I will give you for writing. Note down this. Over. Now we will go for next. So I will rub this now. So let me repeat. What we have discussed now is about equipotential surface. And now we have come to know that equipotential surface is the surface for which potential is same everywhere. The surface for which potential is same everywhere. Number one, A. This is the equipotential surface. Suppose if I will have like this, then what will be the equipotential surface? This will be the equipotential surface. Here also, this is the electric field. Here is the potential which will be same. Getting my point? Now, suppose I don't have uniform electric field in the region. Then, can I say that in the non-uniform electric field, the equipotential surface will not be there? No, not like that. Suppose I take a positive charge. So its electric field will be radially outward. This you are knowing. We have learned this many times. So electric field as for the positive charge, they are going radially outward. तो बेटा now ऐसा कंसिडर करो जैसे ये है, इसको मैंने अगर ऐसे किया तो अगर स्फीयर का एक पार्ट ले लोगे आप, एक कौन सा भी स्फीयर एक सेंटर है, इस डिस्टेंस पे एक पार्ट ले लो, कौन सा भी ऐसा ऐसा ऐसा. सो लाइक दैट सपोज इफ आई विल ड्रॉ द सर्कल हियर, सो every point is at same distance, suppose r from this, correct? Every point is at same distance r. So here also this surface will be equipotential surface. This surface will also be equipotential surface where this will be electric field. So this is also the equipotential surface. This is also the equipotential surface. So for this surface, how we can draw? This surface can be drawn like this, for which electric field is always perpendicular to the area and electric field is parallel to the area vector. So I will suggest you to draw these all types of equipotential surfaces. Okay. Write this. Over. Now, number one, we will write equipotential surface for a single charge. Equipotential surface for a single charge for which potential is given as 1 by 4 pi epsilon naught q upon r. Q upon r. This will be the potential. So if I will take a single charge and suppose that each locus of point, if I will be this all surface if I see, then at everywhere, at this point also potential will be this, at this point also potential will be this, at this point also the potential will be this. So at each point, okay, at every point on the surface, what I got? Potential is constant. It is having constant value. What is that value? The value is P is equal to 1 by 4 pi epsilon naught Q upon R. So that was about the equipotential surface for a single charge. I will suggest you to note this down. I will suggest you to note this down. Now we will go further. Now, secondly, already we have drawn the equipotential surfaces. Okay. Now we will go for properties of equipotential surfaces. We will go for properties of equipotential surface. I have noted down some important properties that I must give you. In simple words, I will try to explain it. Okay. So write down properties of equipotential surface. We will write properties of equipotential surface. So first of all, we will try to gather the important properties, basic properties. Suppose let me draw this surface like this. This is my equipotential surface. Of course, the electric field will be like this. Suppose like this electric field is there. So in order to give you the good idea, I have shown like this. So for this surface, number one will be the important, that is, wait for a minute. Important number one will be that you can write. Suppose I will show it like this. Number one, potential is same everywhere on given equipotential surface. So whatever the equipotential surface I have chosen, that for that particular equipotential surface, potential will be same everywhere. But this is suppose surface number 1, this is surface number 2. This is also equipotential surface. So number 1, potential is same everywhere on equipotential surface. Potential difference. Second is potential difference between any two points. Potential difference between any two points on equipotential surface is always zero. Potential difference, अगर ये potential same है everywhere at point A, at point B, C, D, whatever it is there, if it is same everywhere, then of course potential difference between any two points on given equipotential surface is always 0. आपको potential difference मिलने वाला नहीं. You are not about to get any value of potential difference. There is no potential difference because of course potential is same everywhere. So what is important of this? What is the importance of this? That is no work is done in moving from no work is done in moving from one point to another point. No work is done in moving from one point to another point on given equipotential surface. On given equipotential surface. So, of course, first of all, I have shown you that potential difference between any two points on the equipotential surface given is always 0. So, what is the meaning of that? If suppose I want to go from here to here, so if there is a charge which has to be placed from here to here, then for that charge, what is required? We will first calculate what is the potential at that point. Then, what is the potential at this point? Of course, what is the potential energy at this point? What is the potential energy at this point? Then it is found that on the equipotential surface, if potential is same everywhere, it itself means that the potential difference between any two points is 0, and it itself means that then if we have to move from one point to another point, we will require no any work. So no work is done moving from one point to another point on given equipotential surface. This is very important. VI. Make it 3 star, 5 star, 4 star, whatever. So once you will go for solving the theoretical problems, sometimes they come, then you will require this. Okay. But what is the thing? If I will select two surfaces separated by distance r, if we consider two equipotential surface then two equipotential surface, then so for example 1 and 2, for example 1 and 2. So I have given the idea in the figure. So if we consider two equipotential surface, for example 1 and 2, potential will not be same for them, as if for individual surface it will be same. मतलब सपोज पहले वाले का पोटेंशियल सपोज है 10 जूल पर कूलम वोल्ट, जूल पर कूलम मीन्स वोल्ट, एंड दूसरे का है सपोज 5 वोल्ट. देन ऑफ कोर्स दिस इज 10, so this may not be 10, will not be 10, more or less than 10, more or less than 10. Everywhere I will go for 1, that will be 10 volt. Everywhere I will go for 2, that will be 5 volt. But for 1 and 2, if they are different equipotential surface, then it is damn sure that I am damn sure about that the potential will not be same for them. Individually the potential may be constant. Individually maybe not. It will be constant. Okay. So this also you have to note down. So I will suggest you to note this down. Okay. So these are the 3 important points. One more is there. If we want to calculate the potential difference between the 2 surfaces, then how to deal with that? Okay. So I will rub this as I have expected that we have noted down, and we will try to calculate the potential difference between given 2 equipotential surfaces. Okay. So how to calculate the potential difference? It's very simple. If you will, you have understood about the potential and potential difference properly, then you will not face any problem. You will get a good idea. So potential difference. Suppose this is one equipotential surface and this is another equipotential surface. Okay, they both are for the given same electric field. Only there are 2 surfaces. So one I will show by red first surface and next surface I will show by blue. Okay. So now what will happen? I will call this surface to be 1 and this 2, and this distance I will call it as R. So suppose 2 equipotential surfaces 1 and 2 separated by distance R in electric field E. So suppose I am having 2 equipotential surfaces which are separated by distance R in the electric field. Then number 1, potential difference between them. Potential difference, how much it will be? V1 minus V2 or V2 minus V1. V2 minus V1. How we can calculate? Then I have given you the idea that V is equal to ED. E is equal to minus dV by dr, and dV will be E dr, E dot dr, है ना? E dot dr. So here, as I am going from here to here, the dot product means there will not be any cos component, because cos 0 will be 1, 0 angle is there. R is also along this line, E is also along this line. So यहाँ पे if I will go for that, so it will magnitude of E in magnitude of dr into cos 0, cos 0 will be 1. So dV will be just E dr and V will be integration E dr. Understood? But integration no need to do that, because here the field is uniform. So as the electric field is uniform, so we can write ER. Okay, V2 minus V1, ER. If electric field is non-uniform, मतलब ऐसे किया है, इलेक्ट्रिक फील्ड ऐसा है, रेडियल. Okay, and here I have considered 2 surfaces. Surface number 1 and surface number 2, separated by distance R. Then here V2 minus V1 we can write integration E dot d. Okay, so we can do that. This is some sort of more information about the equipotential surface. I will suggest you to note this down, then we will go for further information. Now we will draw some equipotential surface. Already we have drawn that, but with the properties. Okay. So first for single charge you have written down. Now equipotential surface for different combinations I am having with me. Okay. First of all, we will go for equipotential surface. Number one, single charge. Just now we have noted that, but now I will give you some extra information about that. तो क्या होगा? Suppose this is a charge Q. Charge Q. Okay. This is say radius R1. So I have drawn one surface. Okay. And this is suppose radius R2. And I have drawn one more surface. So you are knowing that electric field will be how? Electric field will be, this will be the electric field. Okay. So very faint drawing I have made for electric field because we don't want electric field. Means we want it, but now it is considered that you are knowing that electric field will be like this. Now, this will be my surface number 1 and this will be my surface number 2. So, surface 1, second, surface 2. Now, potential at the surface. Okay. How much it will be? Okay. So, first of all, V1. V1 कितना है बेटा? 1 बार 4 pi epsilon naught Q upon R. Second will come V2 1 by 4 pi epsilon naught Q upon R2. I suggest you to note this down. दो सरफेस निकाला है, चार्ज सिंगल है, तो दो सरफेस ऐसे हैं, एक का रेडियस R1 है, दूसरे का रेडियस R2 है, वो लोकस है. तो पहले के लिए I'll get the value of potential to be V1 is 1 by 4 pi epsilon naught Q upon R1. सेकेंड के लिए मिलेगा V2 is 1 by 4 pi epsilon naught Q upon R. बन गया. Now if I will go for V1 to V2, then potential difference V1 minus V2 will be, how much it will come? 1 by 4 pi epsilon naught Q upon R1 minus Q upon R2. So what will be the potential difference? So V1 minus V2 can be written as 1 by 4 pi epsilon naught, Q भी बाहर आ सकता है, Q by 4 pi epsilon naught 1 by R1 minus 1 by, that is R2 minus R1 upon R1 R2. So lastly what we can write? Therefore potential difference, ध्यान से इसको देखो, it's very important. Naturally always you will be in the need of this. Potential difference कितना लिखेंगे? Directly we can write Q into R2 minus R1 upon 4 pi epsilon naught R1 R2. This is the very important formula which will be helpful a lot for you. As your problem solving is concerned, this formula will help you a lot. So I will suggest you to note this down, then we will go for next one. Okay. So note this down. Okay. Now we will go for equipotential surface for dipole. So first of all, let us draw a dipole. Dipole will be made up of minus q, क्योंकि उसको दो चार्ज है, इंडिविजुअल एक चार्ज नहीं है, ये प्लस q. Correct. Now, if you start, I will roughly show you. If you start from minus q and if you have plus q. So now if you start from minus q, the electric field lines will be like this. Sorry, like this. And from plus q it will be like this. Okay. Now, if we want to calculate for dipole, then you have to write down whatever I am giving you. Dipole can have many equipotential surfaces in between the given two charges. Okay, dipole can have many equipotential surfaces between any two given charges. One of the equipotential surface will be, कौन सा होगा? तो हमने पढ़ा है, क्या पढ़ा है? तो potential on the equatorial line of the dipole is 0. पलट के देखो, 2-3 लेक्चर के पहले या कल ही दिया होगा मैंने, या कल या परसों दिया होगा, उसको पलट के देखो. I have given you for the dipole. I was wearing orange shirt, and that also I am recognizing. At that time, just I think I explained it. So if you draw the equatorial line, then I am knowing that on the equator everywhere the potential is 0. So one of the equipotential surface, if we want to draw, then you can draw it like this. So one of the equipotential surface for dipole, one of the equipotential surface for dipole is its equatorial plane. Equatorial plane बन जाएगा उसका. So these two places you have to go with. Okay, so I will suggest you to note this also down. Okay. So now madam, we will move further and we will try to get the idea about the next. Okay. So I hope you have nicely understood the fundamentals about the equipotential surface. Now suppose I will draw some different combination. This is plus charge and this is also plus q. So you are doing that plus q, they will repel each other, है ना? So for first q, the electric field lines will be like this, then slowly they will be deviating, है ना? Simple we have to show, for dipole also we can go, because they are negative na? So they will repel. Suppose positive q and here is also positive q, so they will try to go out like this. So now what will happen? So like this, if electric field is there, so what to do for that? तो इसका हम नहीं निकालते, इलेक्ट्रिक फील्ड निकाल के लेते हैं, और उसके लिए क्या हो सकता है, that also we will try to understand. Suppose the electric field is like non-uniform. Now you may be in problem. Sir, priorly it was having same electric field, parallel it was. Then sir, how to calculate for this? How to calculate for this? That you may ask me. So beta, once we are having like this character, like this, what we are doing, direct we were taking, है ना, like that surface we are taking. Now here you have to find the point. You have to find the point at which the electric field will be same. Okay. So suppose, let me draw. Suppose this is the point. Here the electric field is like that. This is the point here electric field is like that. This is the point here electric field is like that. This is the point where electric field is like that. This is the point where electric field is like that. Okay. So we will find the points where we will get parallel same electric field, at least parallel. So यहाँ पे क्या करना है आपको दिखा दूँ, ठीक से निकाल दो, एकदम बढ़िया नहीं बन जाएगा. And this is only just like a knowledge point of view. मतलब you have to get it, understand it, and wherever you have to apply, you may apply that. There is no that much of difficulty in applying that. Suppose I will draw this line. This is like this, it is coming, like this it is coming, and like this it is coming. Okay. Now, suppose this is a point at which electric field is like that. Then I will try to find out where I can get actually say electric field which will be same. So यहाँ पे देखा, फिर यहाँ पे एक लाइन उसको वैसे ही जा रही है, यहाँ पे थोड़ा सा इधर से जा रही है, तो यहाँ पे भी थोड़ा सा इधर से जा रही है. तो अभी ये जो पॉइंट है, अगर इसको लेने वाला अगर मैंने प्लेन पकड़ा, then that may be my equipotential surface. So that you have to find. On the other hand, suppose equipotential surface is given as a tilted one like this. Suppose जैसे अलादीन के किसने देखा है? बचपन में आपने देखा होगा, बचपन में अभी भी छोटे ही हो, अलादीन का चटे था, है ना, वो चटे पे उड़ते जाते थे, है ना, तो कुछ तो वो दिए को घिसता था, वो ये आता था, आई डोंट नो दैट. तो यहाँ पे भी क्या, तो यहाँ पे इलेक्ट्रिक फील्ड लाइन है, तो अगर मैंने ये सरफेस के लिए लिया, ऑफ कोर्स आई विल कम टू नो लाइक दैट दिस विल बी द इलेक्ट्रिक फील्ड, है ना. नाउ फॉर दिस इट इज लाइक दैट. यहाँ पे सपोज इलेक्ट्रिक फील्ड ऐसा हो सकता है. सो लाइक दिस decisions you have to take by observing the given shape of the equipotential surface. So from the shape of the equipotential surface we can easily understand what is about the electric field for that surface. Okay, प्लेन शीट के लिए तो रेगुलर रहेगा, वो दिखाने का जरूरत नहीं है. ओके, so in this way we have completed the equipotential surface. Okay, some questions are there, some problems are there, we will try to find out. Okay, problem number 1, it is very important. Problem number 1 सिंपल है, कुछ इधर उधर करने का जरूरत नहीं, आराम से आ जाएगा. An electric field exists in a space as an electric field exists in a space as E is equal to 2 I cap plus 3 J cap plus 0 K cap. Find the potential difference VA minus VB between the points find the potential difference VA minus VB between the points A 2, 0, A 2, 0 and B 1, 0. B 1, 0. Options -5 plus 5 10, none of this. Options -5 plus 5 plus 10, none of these. So these are the options A, B, C. Sorry, what I have. Okay, so I'll suggest you first write down this and we'll try to solve it fast. Write it down. Electric field, how it is given? E. So given electric field with 2 I cap plus 3 j cap plus 0. Okay. I want to calculate the potential difference. Points are given. A is 2, 2, 0. 2 to 0, है ना? Yes. It means that what will be RA, position vector of A? 2 I cap plus 2 j cap plus 0 k cap. ये आपको ध्यान में रखना। जब आपको दिया है पॉइंट तो आपको निकालना है उसका पोजीशन वेक्टर निकालना। दूसरा दिया B is given 1, 1, 0. So RB will be 1, that is I cap, 1, that is j cap, 0 k cap. Okay. Now VA minus VB can be written as, of course, integration vector E dot vector dr. Vector E dot vector dr. इंटीग्रेशन करने का जरूरत नहीं यहाँ पे क्योंकि यहाँ पे डायरेक्टली वेक्टर दिया है, तो डायरेक्टली हम लिख सकते हैं E dot dr. That is magnitude of E dot डायरेक्टली R लिख सकते हैं magnitude of R, लेकिन ये 2 है बराबर, इसीलिए मैंने वो आपको ये दिखाया था। क्या दिखाया था? E dot dr में दिखाया था। तो ठीक से हम कैलकुलेट कर वो करना ही पड़ेगा। RA VA minus VB RA to RB वेक्टर E dot वेक्टर dr, ये क्या बन जाएगा? इंटीग्रेशन E dr cos थीटा। बट E dr cos थीटा करने का जरूरत नहीं है क्योंकि dr का इंटीग्रेशन R आएगा E dot R और उसको बाद में क्या करेंगे? RA to RB, that is E dot RB minus RA हो गया। तो पहले E का मैग्नीट्यूड निकाल दो। E का मैग्नीट्यूड कितना आएगा? डायरेक्टली लिखता हूँ मैग्नीट्यूड ऑफ E 2 स्क्वायर 4 प्लस 3 स्क्वायर 9, 4 प्लस 9 30 रूट 30, करेक्ट, रूट 30। मैग्नीट्यूड ऑफ RB 2 स्क्वायर 4 2 स्क्वायर 4 4 4 8 8 रूट 8, इसका आएगा मैग्नीट्यूड ऑफ RB ये रूट 30 रूट 8 माइनस रूट 2 है ना। तो ये कैसे लिखेंगे? रूट 30 रूट 8 मतलब 4 टू 8, 4 को बाहर निकाला 2 रूट 2 माइनस रूट 2, तो इधर से रूट 30 इधर से 2 माइनस 1 रूट 2 2 माइनस 1 1 13 टू 26, तो एक्चुअली 26 आना चाहिए, नहीं आ रहा है, कुछ तो गड़बड़ है। 2 3 0 2 2 0 1 1 0 डॉट प्रोडक्ट निकाले ना। हाँ डायरेक्टली, अरे डायरेक्टली भी कर सकते हैं, डॉट प्रोडक्ट ऑफ वन ये करने का जरूरत ही नहीं है, ये भी नहीं जरूरत है अभी मेरे को समझ। अरे इसका आर बी माइनस आर ए कर, सो आर बी माइनस आर ए 2 माइनस 1, सो आई कैप आर ए माइनस आर बी, बी ए माइनस आर ए माइनस आई बी 2 माइनस 1 आई कैप प्लस जे कैप, आई कैप प्लस जे कैप, एंड इलेक्ट्रिक फील्ड कितना है ई 2 आई कैप प्लस 3 जे कैप। इसका डॉट प्रोडक्ट ले लो ई डॉट आर, तो ई डॉट आर कितना आ गया, अब ये आर मतलब आर ए माइनस आ गया, इसको मैंने आर बताया, देखो ठीक से देखो, तो कितना हो जाएगा 2 वन सा 2 आई कैप, सॉरी आई कैप नहीं 2 प्लस 3 वन सा 3 5, now it is plus or minus 5, that depends on if you go for from RA to RB or RB, so यहाँ पे RA minus RB it is given, so it will be plus, so plus 5 volt will be the answer, this will be your answer. So I will suggest you note this down. Next we will again solve one more problem, okay, so that we are ready for second problem, and note this down. ओके बेटा, हो गया, अभी सॉल्व करते हैं सेकंड प्रॉब्लम। ये इसको वी एंड टी करो, लाइक दिस टाइप ऑफ प्रॉब्लम्स मेनी टाइम्स दे कम फॉर योर जेई, आल्सो फॉर योर सीईटी ज़्यादा नहीं लेकिन जेई को ज़्यादा, सीईटी पे आते हैं ऐसा कुछ नहीं, जेई के लिए इम्पॉर्टेंट एकदम इम्पॉर्टेंट। बेटा व्हाट हैपेंस मेनी टाइम्स यू कम अक्रॉस मेनी इजी प्रॉब्लम्स, only the thing is that you are not practicing them and you find them difficult. ये कितना easy था, जिसको डॉट प्रोडक्ट आता है, those who are knowing dot product they will be easily understanding, they will be easily solving them, okay. So you also you keep in mind आपको डॉट प्रोडक्ट वगैरह ठीक से लिखना चाहिए। हाँ, एक बार आपको डॉट प्रोडक्ट कैसे करते हैं वो भी दिखाता हूँ, क्योंकि अगर आप भूल गए तो दिखाता हूँ। रिवीजन ऑफ 11 इम्पॉर्टेंट पॉइंट्स, हाँ जिन्होंने उस टाइम ध्यान में नहीं रखा होगा उनके लिए 2 मिनट में, अभी मेरे को टाइम मिला है तो डॉट प्रोडक्ट कैसे करते हैं, डॉट प्रोडक्ट या उसको ही बोलते हैं स्केलर प्रोडक्ट। जिन्होंने 11 में नहीं किया है वो अभी एक्चुअली उनको अभी तो एटलीस्ट करना चाहिए, है ना। Suppose A is given as AX into I cap plus AY into J cap plus AZ into K cap. AX is the X component, AY is the Y component, AZ is the Z component. दूसरा दिया है B. Suppose B is given BX into I cap plus BY into J cap plus BZ into K cap. Now what happens? That I can write A dot B as AX into BX, I dot I is 1. It will be simple, AX BX plus AY BY plus AZ BZ, X BX plus AY BY plus AZ BZ. For example, 2 I cap माइनस J cap प्लस K cap, ये हो गया, और दूसरा I cap प्लस 2J cap प्लस K cap, हाँ इसको बोलता हूँ मैं X नहीं बोलता P बोलता हूँ इसको, वेक्टर P, इसको वेक्टर Q बोलता हूँ। तो P डॉट Q क्या आएगा, P डॉट Q कैसे आएगा, 2 वन सा 2 माइनस, ये प्लस माइनस 2 वन सा 2 प्लस 1 वन सा 1, ये चला गया 1, इसका डॉट प्रोडक्ट 1 है। दिस इज द वे इन विच वी कैन टेक द डॉट प्रोडक्ट। सो आई रिक्वेस्ट यू दोज हु हैव नॉट अंडरस्टूड or they want to remember that and note down this dot product, you can note down so that you will be able to do it afterwards, okay. Till that I will have some water, note this down, okay. Now we will go for the next problem, और एक प्रॉब्लम सॉल्व करते हैं आपके लिए। write down an electric field potential in an electric field. Problem 2. In an electric field, comma, potential at a point with position vector, potential at a point with position vector are given as V is equal to 343 upon magnitude of R. V is equal to 343 upon magnitude of R. The electric field at R equal to the electric field at R is equal to 3I plus 2J plus 6K. 3I plus 2J plus 6K is. अब इसका ऑप्शन देखो, ऑप्शन थोड़ा सा लेंथी है लिखने में, मैं आपको लेफ्ट साइड को लिख के देता हूँ. I will suggest you to solve this. 21I cap plus 14J cap plus 42K cap. B आएगा 3I cap plus 2J cap plus 6K cap. C आएगा 3I cap plus 2J cap plus 6K cap upon 7. और D आएगा minus 3I cap plus 2J cap plus 6K cap. In an electric field, potential at a point with position vector R is given as this. So given potential here, V is 343 upon magnitude of R. R कितना दिया? R दिया है. डायरेक्टली मैग्नीट्यूड उसका लिखते हैं. मैग्नीट्यूड कितना है? रूट ऑफ 3 स्क्वायर 9 प्लस 2 स्क्वायर 4 13 हो गया. 6 स्क्वायर 36 46 plus 3 49. रूट 49 दैट इज 7 है ना. हो गया. V मिल गया, R मिल गया. E इज इक्वल टू V बाय R. डायरेक्टली कर सकते हो, लेकिन यहाँ पे आपको दिया है ये, तो यहाँ से इलेक्ट्रिक फील्ड का मैग्नीट्यूड मिलेगा, डायरेक्टली कर नहीं सकते. तो आपको क्या करना पड़ेगा? dV बाय dr है ना. तो ये यहाँ पे V कितना आएगा? 343 अपॉन 7. 7 4 जा 28. 7 9. सो V आ गया 49. V मिल गया 49 है ना. V 49 मिल गया. ओके. और इलेक्ट्रिक फील्ड आपको पूछा है, तो भी V मिल गया. E विल बी V बाय R. तो डायरेक्टली 49 बाई 7 है ना. 7. सो जिसका मैग्नीट्यूड 7 आएगा वो आएगा. ये 326 इसका मैग्नीट्यूड कितना आता है? 49. तो मेरे ख्याल से ऑप्शन होगा C विल बी योर रिक्वायर्ड ऑप्शन. सो आई विल सजेस्ट यू टू नोट द प्रॉब्लम एंड ट्राई टू solve the problem. Okay. Now I will give you one more question that we will solve. Okay. This is problem number 2. We will go for problem number 3. In problem 3, the electric potential over a certain is given. So V is given as 3x square y minus, this is also of different type, 4 4xz minus 5y square. Determine the components of the electric field and evaluate at point R. Determine components of electric field and evaluate at the point 1, 0, 2. Okay. What are the components of electric field? Simple. Components of electric field. ये आपको सॉल्व करके देता हूँ. Components of electric field. Ex will be x component, Ey will be y component. Okay. तो बेसिक फॉर्मूला क्या हो जाएगा? बेसिक फॉर्मूला आपको याद होगा. बेसिक फॉर्मूला E is equal to dV by dr. E is equal to minus dV by dr. तो V को डिफरेंशिएट करने का हो गया. तो x कंपोनेंट क्या आएगा? Ex will be minus dV by dx. Ey will be minus dV by dy and Ez will be minus dV by dz. तो एक एक करते हैं. डिफरेंशिएट करने का है तो पहले Ex dV by dx. So d by dx of this, d by dx of 3x square y minus 4xz minus 5y square. बराबर. तो ये क्या हो जाएगा? x किसमें है? ये दोनों में है, इसमें तो नहीं है. तो y कांस्टेंट रहेगा. 3x स्क्वायर का डेरिवेटिव x स्क्वायर का 2x, 2 3 का 6. सो 6xy, y तो कांस्टेंट रहेगा. माइनस यहाँ पे x का डेरिवेटिव 1, 4z आ गया. सेकंड क्या करेंगे? अभी उसको we will differentiate with respect to y. So d by dy of same 3x square y minus 4xz minus 5y square. मतलब यहाँ पे कितना आएगा? अभी y का है तो यहाँ पे आएगा 3x square. यहाँ पे y नहीं है, 0 बन जाएगा. और यहाँ पे minus 5y square, 5 to the 10 minus 10y ये बन जाएगा. माइनस dv by dz. हाँ ऑफ कोर्स. और इसका माइनस भी आएगा ना, ये माइनस, ये भी माइनस. बराबर. इसका कितना आएगा? d by dz माइनस 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 d by dz ऑफ सेम 3x square y minus 4xz minus 5y square. यहाँ पे भी माइनस ऑफ, पहले में z नहीं 0 हो जाएगा. यहाँ पे z 1 आएगा minus 4x minus 0. यहाँ पे भी नहीं है z minus 4x. और इवैल्यूएट एट पॉइंट. पॉइंट कितना दिया है? 1, 0, 2. मतलब x1 y0 z2. बराबर. यहाँ पे वैल्यू डालते हैं xy, x1 y0, ये 0 बन जाएगा. माइनस ऑफ 4z, 4 to the 8 माइनस 8 माइनस माइनस प्लस. सो 8 न्यूटन पर कूलम. यहाँ पे कितना मिलेगा बेटा? यहाँ पे मिलेगा x स्क्वायर में 1 का स्क्वायर 1 माइनस इंटू ब्रैकेट 3 into 1 3 माइनस 10 into y 0 मतलब माइनस 3 आएगा. माइनस 3 न्यूटन पर कूलम. और यहाँ पे कितना आएगा? माइनस ऑफ माइनस 4 into 1. सो माइनस प्लस 4 मतलब 4 न्यूटन पर कूलम. सो इन दिस वे we have tried to evaluate the values of components of electric field. I hope you have understood that. Let me repeat the explanation of this problem, of course, for you people, so that you should not be in problem. तो क्या किया? अपने को दिया है पोटेंशियल. कितना दिया है? 3x square y minus 4xz minus 5y square. What they have told to calculate? Determine the components of electric field and evaluate at the point 1, 0, 2. तो कंपोनेंट ऑफ इलेक्ट्रिक फील्ड, पहले इलेक्ट्रिक फील्ड के लिए जो मैंने आपको फॉर्मूला दिया है E इज इक्वल टू बेसिक फॉर्मूला. इसको बेसिक फॉर्मूला बनाना है. तो बेसिक फॉर्मूला आपका क्या हो गया? E is equal to minus dV by dr. It means that we have to differentiate V with respect to given R. अभी R मतलब क्या है? R का मतलब ऐसे आता है, R को लिखते हैं x into I cap plus y into j cap plus z into k cap. तो R कैसे लिखेंगे? x, y, z के टर्म में लिखेंगे. तो dV by dr कैसे आएगा? Of course, Ex. If I want to calculate, then I will differentiate with respect to x. Ey, then I will differentiate with respect to y. And if it is Ez, then I will differentiate with respect to z. So first of all, if I am differentiating with respect to x, then I will be getting the differentiation of 3x square y minus 4xz minus 5y square. Of course, that will come out to be 3x square y, x square derivative 2x, 3 to the 6, 6xy minus 4z minus. यहाँ पे बेटा y is there, so here y, this will be 0. So y will be 1, 3x square, so that will be same 3x square. यहाँ पे y square, so 5 to the 10y. And यहाँ पे z एक ही में है, तो ये 0 हो जाएगा, z का वैल्यू 1 minus 4x. After that if I put the values, x के लिए 1, y के लिए 0, z के लिए 2. So if I put those values, then I will be able to get this thing. So I suggest you to note this down. So friends, for today I think it is enough. You also watch the lecture. Try to watch the lecture twice, thrice, so that you will be having a good idea. Because this concept is a vast concept. I know that you may be facing many problems while dealing with that concept. So I suggest you to watch it multiple times. Take your own time, make your notes whenever I am telling you. Tomorrow we will come up with I think capacitor and the capacitance. So till that, stay home, stay safe and stay tuned with physics. Thank you. Thanks a lot. Happy learning. Bye bye.